Hi guys, we are going to continue with endurance. As I told you, this is a short version. If you would like to know more, this is the book that you can find at Amazon and you can buy it. Okay, so we are going to talk about endurance. But before we talk, I have to tell you that, of course, we can focus on top sport and we can focus on health. So this study was done in the United States, published in a very prestigious journal called Science. Very interesting study. They put 2,000 rats on the treadmill and they measured how long they can run. They selected the test worst runner, male and female, and 10 best runners, male and female rats. Bad runners were paired by bad runners, good runners were paired by good runners. No training. After the 11th of generation that you can see, the running distance of bad runners was about 200 meters and the running distance of good runner was about more than 800 meters. So this is the running distance. Is it interesting? Okay, of course, in some part. But see, if you see the blood pressure was much higher of the bad runners than at the low runners. This is the better low capacity running, high capacity running. So this is the bad runners, this is the good runners. And if you see the artery response, how rigid the artery was, you can see that low capacity runners had more rigid artery than good capacity runners. And if you see the lifespan, it's also shocking. The lifespan of poor capacity runners and good capacity runners. Huge difference. So what I want to point out that endurance exercise is important not just for the performance, but also important for health. I have a good endurance. So, when we talk about endurance, it is also a result of different kind of capacities. Aerobic capacity is important. Anaerobic capacity is important. The economy of the exercise is crucial. We have an aerobic power, affects the anaerobic threshold, and these all influence the endurance of the performance. It is also have to point out that endurance capacity in a certain degree, it is important for all of the sport. Even important for, let's say, a shot putter. Okay, we can say why. Shot put is, let's say, 2 seconds or so. Why I have to do long-term exercise for shot put? You don't need to have a high endurance capacity for shot put, but you need a high endurance capacity to the training which is necessary to be good at shot put. Because if you want to be good at shot put, you have to spend many hours in the gym. And of course, if you have higher endurance capacity in the gym, you can do more at higher intensity, and then naturally the response, the adaptive response will be better. So what I want to point out, that for the training or even a short-term exercise, for the training you need a certain level of endurance. Otherwise, you cannot be successful. So endurance for everyone, and endurance is extremely important for health. If we talk about aerobic capacity, which is assessed by the maximal oxygen uptake, maximal oxygen uptake is negatively correlated with mortality. So if you have a high VO2 max, you have a less chance to die from cancer, cardiovascular diseases, and so on. So this is another important point. So this is the energy usage and this is the intensity. needless to say that if you increase the intensity, you do that, and you use more energy. And what you can see after a while, this is the light blue bars. You can increase the energy use from aerobic system, and then it is plateaued. But if you see the performance is still increased, because after a certain degree, we can add anaerobic metabolism. So altogether, the energy usage from aerobic and from anaerobic capacity. So question is how we give the intensity at endurance sport. In the gym, it's easy, because if you go to the gym, intensity is given as a 1 repetition maximum percentage. Okay? So if you can push 100 kilo as a maximum bench press, this is 100%. And 80 kilos, 80%. How the situation in endurance is much more tricky. So in case of endurance, either we give the intensity as a percentage of maximal oxygen uptake, we are going to talk about this, or either you give the intensity as the maximum heart rate. Both can work, but naturally not the same. So what is maximal oxygen uptake? Maximal oxygen uptake is a capacity called aerobic capacity, the amount of oxygen that you can uptake during exercise in 1 minute period divided by body weight. And the maximal value is called maximal oxygen uptake. You can see different kind of sport. We get different maximal oxygen uptake ability and capacity. We can see the sports here, the age. Age is important, naturally. You can see the gender. Generally, we can say that male athletes have higher VO2 max than female athletes. And depending on the sport, just some example. Let's see. Gymnastic is about 50 to 58 milliliter kilogram per minute for male and 40 to 50 for female. Rowing, 60 to 70 for male and 55 to 58 to 65. So you can see sports specific differences. Generally, if you have higher VO2 max, it's an advantage at endurance sport. So therefore, one of the aim of the endurance training is to increase maximal oxygen uptake. But first of all, we have to find out what is maximal oxygen uptake. Maximal oxygen uptake is a result of stroke volume. How much blood, cardiac output, how much blood you can pump out by the left ventricle. So naturally in this part, heart is one of the limiting factor of the maximal oxygen uptake. Therefore, we need a training which increase heart capacity, so-called cardiac exercise, cardiac training. This is one of the importance. So what kind of exercise could be good for the heart? Usually I would say that if the intensity is low, I would say 60 to 70% of the maximal oxygen uptake with a relatively long duration, let's say more than 30, 40 minutes, or even longer than 1 hour, this kind of exercise training is really beneficial for the heart. And if you do this kind of training, you can achieve increased left ventricle volume. And of course, you can teach also your body to use fat as an energy source. If you want to learn the details, why this is happening and how to do that, go to the book. So the heart adaptation is quite different if you have adaptation to aerobic training, or if you have adaptation to resistance training or strength training. If you have if you do resistance training, your heart always have to work against increased peripheral resistance, and as a result, the wall thickness of the left ventricle will increase. The size is increasing a little bit, but the left ventricular volume will not increase. On the other hand, if you use aerobic exercise, and if you do so, your body is working against decreased peripheral resistance, so the left ventricular volume going to increase, and this will or could result increased maximal oxygen uptake, because heart is one of the limiting factors. So naturally you need training for the heart. What are the other parts? So let's say this table shows you of the suggested estimated levels of different kind of heart parameters, endurance parameters of untrained, trained and well-trained individuals. So what you can see, the ventilation during rest is about 12-15 liters per minute, and in case of maximal loading, it can be over 220 liters per minute. Cardiac output, 5 liters during rest, and it can reach 40 liters during maximal loading. Heart rate goes up from 70 to 200. Stroke volume against to 70 to 200. Maximal oxygen uptake, milliliter kilogram per minute, from 35 to 85 milliliter kilogram per minute. An anaerobic threshold, the value from which you switch from aerobic metabolism to anaerobic metabolism, is about 85% of the maximal oxygen uptake. This is extremely important because it is related to the economy of the movement. This graph actually shows how arteries, capillaries are responding to the exercise, and how the blood pressure is regulated by the enzyme called nitric oxide synthase, and which is producing nitric oxide, which then results in the relaxation of the smooth muscle cells and increased dilation of the arteries. So maximal oxygen uptake is also influenced by capillarization. What does it mean? It means that if you have more capillaries in the skeletal muscle, you could have increased maximal oxygen uptake. Why? Because the muscle can uptake more oxygen from the coming blood. And so in order to increase capillarization, you probably need, again, a special training for that. If you have aerobic exercise, then there is a need and the supply is balanced. So this kind of situation would not really induce increased capillarization. Why? Because what I need, I got. So I don't need more, and there is no mean for the body to invest energy to generate more and more capillaries. On the other hand, if you do anaerobic exercise, high intensity exercise, let's say interval training, then the muscle will not get enough oxygen. It suffers a kind of suffers from some kind of hypoxic condition. So what does it mean? We need more than we can get. As a result, muscle will start a very interesting cellular signaling process in order to generate more capillaries. Every cell has a system which sensing the oxygen availability. So there is a protein called hypoxia-inducible factor 1 alpha, HIF protein, and this HIF protein is sensing the oxygen availability. If you are suffering from hypoxic condition, oxygen depth, then you activate HIF alpha, and then HIF alpha gets into the nucleus, attached to certain part of the DNA which is responsible for coding of those genes which are generating more capillaries. Vascular endothelial growth factor as an example. So activation of this process would enhance capillarization in the skeletal muscle. So in order to do that, you have to choose exercise which has a high intensity exercise. It's pretty interesting because right now, actually we are talking about how to improve maximal oxygen uptake, which is aerobic capacity, but you have to do anaerobic training in order to aerobic capacity to increase capillarization. And this is not the end of the story, because one extremely important organelle of the cell is mitochondria. Mitochondria is producing ATP, and naturally for endurance exercise you need a lot of ATP, so you need a lot of mitochondria. So this is the pioneering work of John Holosy. He unfortunately passed away some years ago. He was brilliant, one of the best sports scientists in the world. So he published this paper at the Journal of Biological Chemistry, 1968 probably. So long time ago, 50 years ago, more than 50 years ago, and he showed that exercise training increases mitochondrial concentration in the muscle. So by exercise, you can increase mitochondrial concentration of the exercise. And later on, a group from Harvard University, led by Bruce Spiegelman, this slide is copied from his paper published at the Journal of Cell, found out what is the crucial protein to increase mitochondrial mass. He found out a protein called PGC1 alpha, which is a co-activator protein. Mitochondria contains about 1,000 protein, and mitochondrial DNA codes very few, 13 of them, which are located at the electron transport chain, and the rest of these proteins of the mitochondria coded by nuclear DNA. So we need some protein which coordinates the proteins which are located, coded by mitochondria, and those which are coded by nucleus. And this coordinator is PGC1 alpha. So if you overexpress PGC1 alpha in animals, in this case of mice, you got more mitochondria. You can see from the red muscle, more red muscle, more sloth type of muscle here than in the wild animal, and higher endurance capacity as well. So it seems just increasing the mitochondrial number of the muscle would increase the endurance capacity. So, and you have to find out the exercise which most efficiently activates this PGC1 alpha, which is a coordinator of the mitochondrial production. And it turns out that high intensity interval training would be that exercise. So high intensity anaerobic exercise in certain situations would increase mitochondrial number, and then by this increase aerobic capacity. Of course, energy is extremely important. We have different kind of pathways to produce energy. So the energy is ATP. We have to produce ATP. One, if you do exercise, the ATP level is decreasing and then maintained. Decrease, we have some extra ATP which can be used by the contraction, but then a certain level of ATP is necessary to maintain normal cellular processes. So ATP level cannot be zero, because if it's zero, then the cell would die. So we have to maintain this ATP level. We have different kind of pathways. One is we can get ATP from creatine phosphate. So when the ADP is formed, then the creatine phosphate gives the phosphate group to the ADP, generating ATP. In this process, we don't need oxygen, and we do not produce lactic acid. Therefore, this process is called anaerobic lactic process. So this provides energy for a very short period, 6 seconds, not more, and it has a very fast recovery as well. And then we have to produce ATP. We produce ATP from sugar, one glucose. We break down glucose. If we don't have enough oxygen, we break down to pyruvate, and from pyruvate we're going to produce lactic acid. The problem is that this process just gives us 2 ATP from one glucose, and then we have lactic acid. And we learned already that lactic acid is causing fatigue. So generally we can say that when the duration of the exercise with maximal intensity is about 80-90 seconds, then half of the energy, 50%, is provided by anaerobic process, and 50% is provided by aerobic process. As you decrease the intensity further and then increase the duration, then the aerobic process will be more and more pronounced. So aerobic process means from one glucose you are gaining 36 ATP. Very nice. And then, of course, you do not produce lactic acid. That's why it is called aerobic. So the oxygen that you uptake is enough to completely burn glucose. And then, of course, we can also use fat as an energy, but using fat as an energy, we need more and more oxygen because fat oxidation needs more than carbohydrate oxidation, needs more oxygen. And it's not so easy to burn fat. You need a kind of time. So the exercise intensity duration must be longer than 30 minutes because we have to localize fat to free fatty acids. Free fatty acids must go to the site of the contraction. So it takes time. But generally speaking, burning fat is very beneficial. We have more than 100,000 kilocalories stored in fat, and we have about 2,000 something stored at carbohydrates. So huge difference. We store much more energy in fat. So in case of exercise, naturally high intensity exercise use carbohydrate, and low intensity exercise using fat. Those athletes who are very well trained can mobilize fat much faster than poorly trained athletes. So this is extremely important because from where we use energy, it affects many things. It affects fatigue, affects the recovery time. Important to note that everything is mixed up. So even when you sleep, you are producing lactic acid because lactic acid is necessary for neurons as an energy source. So, but when you sleep, you are completely aerobic, but still you are producing lactic acid. And even 100-meter sprint, you take 2, 3, 5, 6 breaths, sometimes even more. So you have also aerobic process as well. So everything is mixed up, but generally speaking, this is extremely important because it shows very nicely the efficiency. No question, aerobic exercise is very beneficial, good quality, and then you have to stay at aerobic conditions as long as it's possible. In order to do that, you have to have a high maximal oxygen uptake. And you have to have a nice exercise economy. See, if you increase the intensity of the exercise, you are going to increase the lactic acid concentration. But the increase is not linear. It is moderate, and then there is a sharp increase. The sharp increase is a kind of plateau here. Plateau is about, I'm talking about mean values always, it's around 4 millimole per liter lactic acid level in the blood. And then there is a sharp increase. So we say that below 4 millimole, this process is called aerobic, and over 4 millimole is called anaerobic, because here we produce much more than we can eliminate. Here we produce lactic acid, but we also eliminating it. Okay, but you can see the difference between untrained and trained athletes with anaerobic threshold. Not 4 millimole in case of both untrained and trained, but the difference is the intensity where you can reach. So let's think about a little bit. Have you ever tried running on treadmill? So I think if you tried about 15, 16 kilometer per hour speed, you die. You cannot really run more than 1 minute or so, and your lactic acid level goes up to the hell. You know, these super marathon runners, during marathon, they run a bit higher speed than 20 kilometer per hour. 20 kilometer per hour for 2 hours, which means that the 20 kilometer per hour speed case, they are still at aerobic condition. And the 20 kilometer, in case of you, 16 would mean anaerobic condition. So what you can do, what you must do by training, you shift this curve, and you have to train your body to stay as long as it's possible at aerobic condition. So the intensity where you switch from aerobic to anaerobic must be at high percentage of your maximal oxygen uptake. So this is the aim. So what kind of exercise would be good for that? I would say exercise where the lactic acid level between 3 and 6 millimole per liter. So when you have a moderate increased activity, so-called threshold training, would be the best to increase the intensity which belongs to the anaerobic threshold. So you can go to high altitude. Naturally, high altitude training is often used to improve the endurance performance. Naturally, those guys who are coming genetically from high altitude have some advantage, but just some. We cannot say that all of them are very good endurance runners. There are so many people living at high altitude in Nepal, Bolivia, or even Mexico, but they are not really good at endurance. But some guys from Kenya who are also coming from Kilimanjaro, from from high altitude tribes, they are good. So just living at high altitude is not enough. You have to train at high altitude, and this is a different story. But if you want to prepare to endurance exercise, which will be at sea level, high altitude training is quite controversial, generally speaking, because if you go to high altitude, your maximal oxygen uptake is decreasing, your maximal heart rate is decreasing, resting heart rate is increasing. So it means that aerobic capacity is decreasing at high altitude without any question. This is what you can see from the result of the Mexican Olympic Games, which was at the altitude of 2,300 meters. Therefore, method was developed by Levine and his co-workers long time ago, more than 30, 40 years ago, which means doing the training at sea level and sleeping at high altitude, which means this intermittent exposure to high altitude is good. So in some places, because if you sleep at high altitude, of course it will disturb the sleep a little bit, but you can get a benefit such as increased production of red blood cells, and then you have and capillarization, and then you have a better oxygen carrying system. And on the other hand, if you do the training work at sea level, you can do the exercise at higher intensity, and you can activate more fast twitch fibers than at high altitude. So this is the story, and I love this graph very much because it shows very beautifully the different response of fast twitch fibers and slow twitch fibers to different intensities. Red soleus muscle is naturally a slow twitch fiber dominated muscle. Citral synthase activity actually shows the mitochondrial concentration, represents. So in case of red muscle, if you increase the intensity of the muscle, running from 20 to 60 meters per minute in case of rats or mice, it will not increase the mitochondrial concentration. But this high intensity actually will increase the mitochondrial concentration at white muscle, you see. So if you want to increase the mitochondrial concentration of white muscle, you have to choose high intensity exercise. On the other hand, if you want to increase the mitochondrial concentration at a red muscle, you have to increase the volume, not the intensity. It's because if you increase the volume to 30 minutes to 2 hours or kilometer, whatever, it means the mitochondrial concentration going to increase at red muscle, and it will not increase at white muscle. So this is extremely important, and it seems mixed muscles are responding to both kinds of training. And other important issue here is called trainability. It seems that our response to aerobic training is pretty different. We have a so-called non-responders, and we have a so-called responders. So some of us who do training will not really respond to the training, and some of us would respond nicely. And we did a study on animals and found out that the trainability of the aerobic exercise is mostly dependent on mitochondria associated factors, not strongly related to VO2 max, but mitochondrial concentration and mitochondria associated factors are probably showing how you can be trained to aerobic exercise or not, how can you adapt. So this is about endurance training. Please read the book if you want to know more. I think. Thank you very much.